You have learned how to consume the result of an asynchronous task. But what if this task throws an exception? For example, let's say we try to call a remote weather service to get the current weather in a given city. Now, this remote call may fail for various reasons. So let's see how we can handle exceptions and recover by transforming an exception into a value. So I'm going to create a completable future object using the supply async method. In the body of this Lambda, first we print a message like getting the current weather, and then we throw a new illegal state exception. The type of the exception doesn't matter. I just want to throw an exception. Now, this returns a completable future. So let's run our program and see what happens. We didn't see anything because this exception was thrown on a different thread. To get this exception, we have to call the get method of the future interface. So if you look at the documentation of the future interface, you can see that the get method returns a value of type v, and it may throw an exception of type interrupted exception or execution exception. So if an exception is thrown on the thread that is executing our task, the get method is able to propagate that exception and bring it into our main thread. Let me show you. So here we call future.get, and then wrap this inside a try-catch block. Then run our program. Now we get the exception. So we were trying to get the current weather, but we got an execution exception. This execution exception is caused by an illegal state exception. So the exception that we threw in our Lambda is wrapped inside an execution exception. So when we call the get method, we may get an interrupted exception. This happens if the thread is sleeping, but we try to interrupt it. Or we may get an execution exception. This happens if something goes wrong during the execution of our asynchronous task. Now we can get the actual cause of this exception by calling e.getCause. This will return the exception that we threw here. Now, we don't want our application to crash. So what should we do here? Well, in this case, we can recover and provide a default value like the last temperature that we successfully read before. Let me show you how to do that. So first, I'm going to delete this line. Before we call the get method, we call another method called exceptionally. Now look at the signature of this method. It takes a function that maps a throwable to a different type. We talked about throwables earlier in the section about exceptions. So this throwable class is the base or parent of all errors and exceptions in Java. So here we need to pass a Lambda that maps this exception to a different type. So we can get this exception and map it to a numeric value like 1. Let's imagine this is the last temperature that we read successfully. Now, when we call the get method, we get the result. That is the last temperature. So let's store it over here and then print it. We didn't get an exception this time. So this is the benefit of using the exceptionally method. Now, one thing you need to understand is that this method will return a new completable future. So this completable future is different from the one we originally created. With this method, we're programming this completable future to return a default value if an exception is thrown. So when we call the get method on this new completable future, we'll get that default value. If we call the get method on the original completable future, we'll get an exception. So this is something that you're going to see again and again throughout this section. A lot of methods in the completable future class return a new completable future. With this, we can build a recipe for our asynchronous operations.